Hi everyone, Ms. Stillman here. This is the homework 3 key for trigonometry. So if you take a look at question number 1, you need to read it and underline keywords and then look at the diagram. What's nice is the string is already put in with a 400 feet and the fact that the 25-degree angle with the ground is already labeled and how far is the end of the string attached to the ground from point directly below the kite. That's already labeled with X. Now we need to know what these numbers mean for opposite, adjacent, or hypotenuse. Well, angle 25 is here, so next to it is adjacent, and then that is across from the 90-degree angle. It's 400 is the hypotenuse. So we think, oh, it's using adjacent, hypotenuse. It's cosine, ka. Here's my little person thinking cosine, ka. Okay, little humor. Now I write down formally that cosine theta is adjacent over hypotenuse. And when you do this, you need to make sure cos is accompanied by the angle of 25. The adjacent is the x, and the hypotenuse is the 400. Now, when you take a look at your cross multiplying, because you're looking for a side, you put it over 1, you cross multiply. Now you can write it as 400 times all this content, cosine parentheses 25, or a little bit more simplified, 400 times cos parentheses 25. Now on the graphing calculator, please make sure your mode is on degree, and then we would type in 400 cos 25. Notice the parentheses are already there. That's 362 point all those decimals. I've written them down. Now let me show that to you with extra parentheses. 400 parentheses cos 25, close parentheses on the 25, close parentheses on the multiplication. It will get you the same answer. So notice that you can write it without the parentheses up there. So now take a look at that number, round it to the nearest foot. That is 363 feet. In the next question, we underline keywords, we look at the diagram. This time we didn't have an X labeled. The height from the ladder, the height that the ladder reaches up the wall, that's the height up the wall. The ladder ends up being right there. So all of this is the height that's being looked for. Now we need to decide what to label that X across from the 74. Well, that's opposite, and that 2.7 feet is adjacent. If we're using opposite and adjacent, we're using tan theta is opposite over adjacent. Now, the tan is of an angle, that's the 74. The opposite is x, the adjacent is 2.75. Cross multiply, you get x equals 2.75 tangent of 74. I'm going to type that into my calculator, 2.75 tangent 74, 9.5903 onward. I'm just going to fit that right over here. 9.5903 dot dot dot. Nearest tenth, 9.6. Now there's a follow-up question. How long is the ladder itself? Well, we just found that the opposite is 9.6. Sorry for my squishing the 9.6, but now you see that two of the numbers we know, one number we don't. Well, in a trig question or any of these real-life examples, the tall object makes a right angle with the ground that's perpendicular to the ground. This is a right triangle, and you can find the missing side C, the hypotenuse in Pythagorean theorem. So take a look. You could do a Pythagorean theorem or trig, but I have it here with Pythagorean theorem. The two legs get squared. You could jump to the total of 99.7225. Square root both sides. You get 9.98611 dot dot dot. Nearest foot is the whole number. And then you get the 10 feet. On the next page, it's really focusing on cofunctions. The very first question, actually above it says cofunctions. You think cofunctions, think 90 degrees. The angles are complementary. So theta, sine theta equals cosine 37. That will be true when the theta and the 37 add to 90, or you can just think 90 minus 37. Either way, you got 53. Very similarly, for sine 55 cosine theta, you get 35. Number 5, sine 4x and cosine 16, they're equal if these two angles add to 90. So take a look at the math here. Go over the solving. I'm going to take a little more time on number 6 because there's a theta symbol, and if you want to combine like terms with theta, it might be a little more complicated when you look at it visually. So these two angles, theta and theta minus 40, are two angles that together add to 90. Just like normal variables, when you combine your like terms, this is like an invisible 1 theta and 1 theta, you get 2 theta. It's not a 0, make sure you know it's a theta. It's a variable for angles. Minus 40 equals 90, plus 40 on both sides. So when you do that, you get 4 theta equals, 2 theta, I looked at the wrong answer key, is 130. Divide by 2, you get theta equals 65. Now that same thing you can do with x's. So you'd get 2x minus 40 equals 90. Add the 40 to both sides, just like we did with theta symbols. You get 2x equals 130. Divide by 2, you get x equals 65. And I probably would follow up, since they're looking for theta, just say the final answer is theta equals 65. If you're using the x, try to go back to the symbol that they are asking for. Same thing over here, you could do with thetas, you could do with x's, but as I mentioned, your final answer really should technically be theta equals that number 9, not the x. So try to write the variable they're looking for. On the last question, which expression is always equivalent to sine x when x is between 0 and 90 degrees? Well, if you're thinking of sine x, all the answers should be about cosine. Well, they didn't try to trick you and throw tangent in there. They all say cosine. Think to yourself, sine and cosine are cofunctions. That means the angles together add to 90. 45 has nothing to do with 90. 2x, sine x is not cosine x. It's this 90 idea. Now, you may be confused as to what that really means. Well, that's like what we did up here in question 3. You took the 90 degrees and subtracted away the angle that you know. That's similar here. We know the angle is x, so it's 90 minus that angle. So just like number 3 has 90 minus 37. Otherwise, just recognize that's the only example that has something to do with complementary 90 degrees.